Hey everybody, thanks for tuning in to our video on solving a quadratic equation by factoring. So yesterday we solved quadratic equations using the zero product property. Well, we're pretty much going to do the same thing, except we're going to have to factor first to be able to use the zero product property. So I would say this is like a step above what we did yesterday. So I've got 6 examples to go through, just showcasing, again, it's just good review on factoring. So let's look at the first one. It says, hey, we're going to solve for u. And the problem is u squared plus 8u minus 9 equals 0. Now, first off, it's this equals 0 part you want to focus on. If we can factor this side into 2 parentheses, right, which is what trinomials do, then we'll have 2 different expressions multiplied together equal to 0, and we'll be able to figure out then by the zero product property what's going on here. The only other option would be to do this granny style. I mean, just to sit here and be like, okay, what could I put for this u and this u that when I do all this math, like I get 0? And you could totally do that, but it could be a little bit more time consuming to do that. So I suggest, well, first I suggest the dog stops barking, but secondly, I suggest that we factor. So let's factor. So we should be getting pretty used to this by now. We're going to be looking here in order to fill our parentheses, and just don't forget the equal 0. This is the new part. We are looking for 2 numbers that multiply to give us -9, but add to the middle, which is 8. So we're going to add to 8, okay? So 2 numbers, they multiply to a -9, but they add to 8. You can pause me if you want to think on your own. I'm thinking 9 and -1. 9 times -1 is -9. 9 plus -1 is 8. So that's what I'm going with. So I'm going to put a u here and a u here, and then a positive 9 plus 9 and a -1. Now we're at the point we were at yesterday. See, we have a product of 2 polynomials set equal to 0. So either, now we're going to do our work, either u plus 9 must equal 0 or u minus 1 equals 0. Solving those down, u is going to equal -9 if we subtract it, or add 1 to both sides, u equals 1. And there you have your 2 answers. Now, if you want to check it granny style, let's plug them in. So if I put -9 in here, let me grab my calculator just to save time on the video. So if I do, can you see that there? Now remember, I'm replacing the u's with -9. So if I have parentheses, -9 squared plus 8 times -9 minus 9. Ta-da! And I get 0, so that works out. Now let me try the 1. I'm going to put a 1 here and a 1 there and see if I get 0. So parentheses, 1 squared plus 8 times 1 minus 9. Ta-da! I get 0. So I kind of think this was faster than just guessing and checking, although you can see the answers do work out granny style as well. Okay, let's go to number 2. Solve for p. So again, we have this expression, p squared minus 26p equals 0. But right now we don't have like 2 expressions being multiplied. Right now we have 2 expressions being subtracted. That's not going to work. So we need to turn this into multiplication of some sort. And I'm thinking we factor by the GCF. So let's factor by the GCF. Let's divide by the GCF. What is the GCF? Well, I'm thinking p. So I'm going to take a p to the front times p squared divided by p is just p minus 26p divided by p is 26. Now I've got multiplication. This times this is equal to 0. That means one of the two things has to be 0. So either P, this guy, is 0, or P minus 26 is 0. And so this is done. We'll add 26 and we'll get P equals 26. So those are my two answers. Do they work? Well, let's go up and see. If I put 0 in here, 0 squared minus 26 times 0 is certainly 0. And if I put 26 in, well, look at this. If I put 26 in, 26 squared means 26 times 26 minus 26 times 26. That's going to be 0 as well. So that's making me feel really good about this. So see how it's the zero product property from yesterday, but before you do it, you have to factor. Okay, let's go to the next one. Number 3, solve for x. 25x squared minus 49 equals 0. This is the difference of two perfect squares. Hopefully you know the shortcut to that from last week. So we break it down. We know one will be plus and one will be minus so that the middle goes and falls out to 0. Now, the square root of 25 is 5, so this is going to be 5x and 5x because 5x times 5x is 25x squared. And then the 49, the square root of 49 is 7, so 7 and 7. There's the negative 49 on the back. And so if you did this whole multiplication back, you would have your 25x squared, your negative 35x, your positive 35x, which would drop to the middle of being 0, and then your minus 49. Okay, two polynomials, two binomials being multiplied to give me 0. So either this guy equals 0 or the second one equals 0. And you solve. So you're going to have to subtract 7. So 5x equals negative 7. And then I'll have to divide by 5. So x will equal negative 7 divided by 5. That's how you're going to put it in IXL. The other one, you're going to add 7. So 5x equals positive 7 and divide by 5. And x will equal 7 divided by 5. And or. What I noticed with this lesson, everyone, when you get to the IXL, they don't have the two boxes they had yesterday. They only have one box. So they have it like this, like x equals, and then they have a box. But the directions at the top say to type both of your answers in here separated by a comma. So you would put in like negative 7 over 5, comma, positive 7 over 5. And you just use like the divided by sign on your laptop. And that's it. Okay? Next one, solve for b. 4b squared plus 12b plus 9 equals 0. To factor this, you know the steps. This is a little bit longer because this is not 1. So we take 4 times 9. That's 36. And then we bring the middle down, 12. So we need two numbers that multiply to 36, but add to 12. In fact, add to 12b. So I know I'm going to have my b's on here. So what do you think? I hope you're thinking 6 and 6. Because that works out really nicely. So I'm going to rewrite 12b as 6b plus 6b. That's going to give me 4b squared plus 6b plus 6b plus 9 equals 0. I'm going to group them up. 4b squared plus 6b plus, group these up, 6b plus 9 equals 0. Don't forget your equals 0. GCF it. Okay, this is going to be 2b. This is going to be 3. So for this guy, 2b front. Leftovers, divide 4b squared divided by 2b, 2b, plus 6b divided by 2b, 3. 3 to the front, divide 6b divided by 3, 2b, 9 divided by 3, 3. And this still equals 0. Now, if I went too fast here, hey, slow it down, pause it, rewind. This is review. This is review, review, review. So that's why I'm kind of cruising through it. Now, to finish the factoring, you see the 2b plus 3 right here and here they have in common. So I'm going to bring that front, 2b plus 3. And then the leftovers, 2b plus 3. So it's like a duplicate, right? Equals 0. And you can check it. This is the factored version. If you do your 4 rainbows, 1, there's your 4b squared. 2, there's a 6b. 3, there's another 6b. That makes the 12b. And voila, there's your 9. Now we're almost done. If this product is 0, then either this is 0, 2b plus 3 equals 0, or the other 2b plus 3 equals 0. But I hope you notice these are going to result in the same answer, because if you subtract 3 here and you get 2b equals negative 3, and then divide by 2, you get negative 3 over 2, you're going to get the same answer here. So there's just one solution here. B equals negative 3 over 2. You don't have to repeat it twice. Awesome. 2 to go. Now, I wanted to show you these two because I did the IXL as a student and I got my SMART score up above 80. And those of you who like to go further and try to get up to 90 or 100, they did put some later on that looked like this. And they look messed up. Don't worry about it. All you have to do is make one simple move to get the right side to 0. Okay, so all you have to do is move the furniture, move the negative 14f over here. So we want to add 14f to both sides, like so. Now, that is going to make the right side 0, which is what we want. Because if we're going to solve a quadratic by factoring, we want that right side to always be 0. Now here, the f doesn't have anybody to join with, so let's just put him in the middle. So we'll make it 2f to the second plus 14f plus 24. And now you have your trinomial. Now the thing I notice about this is there's a GCF to be had here. These are all divisible by 2. So let's get that out. Let's divide by 2. So that'll give me a 2 in the front. And then I have to find my leftovers by dividing. 2f to the second divided by 2 is just f to the second. 14f divided by 2 is 7f. And 24 divided by 2 is 12. And this equals 0. Now, you really do have two things here being multiplied together set equal to 0, but we've got a problem. If you try to set 2 equal to 0, like there's no variable here. You can't set 2 equal to 0. So this 2 is kind of irrelevant in a way. What I can do to get rid of it, and remember, I couldn't do this if I had an f out here with it, but because it's just a plain old 2, why don't we divide both sides by 2, and then we can like squash it from this side because that's a knockout, and then we just have f squared plus 7f plus 12 equals 0 divided by 2 is still 0. So now I can just focus on this and factor this. So let me come over here because I'm kind of running out of room. So I've got f squared plus 7f plus 12 equals 0. So it's good old quadratic. I know, and my leadoff coefficient is 1, so that's easy, f and f. Now I need two numbers that multiply to give me 12, but add to give me 7 in the middle. So that's pretty easy. 4 and 3 is going to be the magic there. So I'm going to have 4 and 3. And now, zero product property says you set them both to 0. So f plus 4 equals 0 or f plus 3 equals 0. Sorry, I'm squishing this in. So my two answers are going to be f equals -4 when I minus the 4 over, or f equals -3. Ta-da! And the cool thing is if you take these granny style back to this original problem, like let's just say you keep it as it is here in black, and you replace the f's with -4, watch what happens. So if I replace this guy with a -4, I would have 2 times -4 squared plus 24, and that makes 56. And then if I take this side, -14 times -4, see how I also get 56? So I would have 56 equals 56. And then if I take the other answer, -3, do the same thing. 2 times -3 squared plus 24. That makes the left side 42. And then if I take the right side, -14 times -3, I also get 42. So these are the two values of f that I can use up top here that makes this original problem true. Okay, last one that I saw on IXL up above 80. Solve for n. Again, a little bit mismatched in the way it's written. We've got 48n squared equals 70n. So the first thing we need to do is move him over here so this is 0. So let's subtract 70n from both sides. That's going to give us 48n squared minus 70n equals 0. And that's what we want. Now we're back to factoring by GCF because it's just two terms and it is a difference, but these aren't perfect squares. So let me GCF this. Obviously they have an n in common. The lower n is just the n. But the 48 and the 70, I'm thinking it's 2, but don't forget, you can use your calculator. If you press math, arrow over to num, and then choose number 9, which is GCD, same as GCF, and type in your coefficients, 48, comma, 70, enter. It is 2, so it's 2. So my GCF is going to be 2n. Okay, so the 2n comes to the front, and then I'm left with, let's see, 48 divided by 2 is 24, and I'll have an n, minus, and then 70 divided by 2 is 35, and the n's drop, so there we have that, equals 0. Now we have two items being multiplied to 0, two polynomials, a monomial and a binomial, so either this equals 0 or this equals 0. And now I can set this equal to 0 because I have 2n, and I can do that. It's not like back here where I just had the 2. I have 2n, so I'm going to have 2n equals 0 or 24n minus 35 equals 0. So to solve those down, divide by 2, n equals 0, or add the 35, that's going to give me 24n equals 35. Divide by 24, and that's going to be 35 divided by 24. And those would be my two answers. And you might say, really? That ugly answer? Yeah? Watch what happens. If I go back to the original black problem here, watch what happens. Let me type in 35 over 24 where these n's are. So left side would look like this. It'd be 48 times alpha y equals, what did I say it was? 35. 35 over 24, kick out, close parentheses, and square it. That is that nasty fraction, 1225 over 12. Now let me do the right side. 70 times the n. Okay, 70 times alpha y equals 35 over 24. Get the same thing. So even though it's ugly, this value of n makes both sides equal, and that's what we wanted. So there you have it. So this is going to go with, these examples are going to go with the IXL that is called solve a quadratic equation by factoring. Okay, make sure it's equal to 0, factor it out, set them both to 0, and solve. Good luck.